covered in this lesson are introduction, electric current, electric components, circuit diagram, heating effects of current, fuse, MCBs, magnetic effects of current, electromagnet, and electric bell. Now, when we talk of electric current, what is something that you can very easily relate to? So, when it comes to electricity, electric current, what comes to your mind instantly? I'll give you an example which we experience in our day-to-day life. So, one such example is when you switch on the light of your room, what happens? You just turn the switch on and the tube light glows or the bulb glows. So the entire room is lit and you are able to see each and everything which is there. Sometimes there is a power cut and what happens? Everything turns dark and you are not able to see anything that is there. Why? Because there is no light. Now when I say that the bulb is no more glowing, what do we mean? We mean that there is no electricity. That's how we say that, okay, there is no electric current, there is no electricity, there is a power cut, and that is why tube lights are not on. Now again, when the power is back, electric current is flowing, so you have your lights on. So that is something where we use the term current in our day-to-day life. I mean, I'm very sure that in these scenarios, we all use the term current. But in this lesson, we are going to understand what exactly is electric current. What do we mean by electric current? What is the science behind electric current? And what are the various properties or what are the various effects of electric current? So that is going to be our agenda in this lesson. Now, before we go ahead with our discussion on electric current, let us look at some of the important applications of electric current. So as I mentioned, switching on the bulb glows. Now, do you know what happens when we switch it on? When we switch it on, basically current flows through a circuit. And due to the flow of current, the bulb glows. So now we will understand all these things in more detail. We will draw some diagrams. We will see how exactly the entire circuit is made up of. But this is one place, this is one instance where electricity plays an important role. Think of this situation where you have an open socket carrying current. And if by mistake you try to go near it or you touch it, what happens? You experience an electric shock. So why do you experience an electric shock? Due to electric current. Similarly, you think of devices like the camera, the battery, one of the most important examples. So do you know how batteries work? So you would have seen a lot of devices starting from torches to computers to your cell phones, and all of them have a cell or a battery inside them. So these batteries, what do? They generate electric current. They produce electricity. So they have a setup inside due to which electricity gets generated. So they generate electric current. So batteries are very important stuff. And in a way, batteries have brought about a revolution in the modern technology. You think of your computers, you think of the normal things at your home like the fan. When you switch it on, it starts, it gets on. The fan moves. That's because of the current flowing through it. You think of the television, the transistor, the mobile phones. So all of them make use of things where electric current plays an important role. Think of your refrigerator. So when there is a power cut, is the refrigerator still on? No. So only when there is power, your refrigerator is on. So electric current has to flow even inside the circuit of a refrigerator. So now let's look at a very common scenario. What could happen if by mistake you touch a wire which is naked and which is carrying current? So the wire is not covered or it is not, it is coated with some other material. It is just a naked wire which is carrying current. Now what can happen if you try to touch it? It can be extremely dangerous. Obviously, you will experience electric shock, and sometimes the shock can be so much severe that it can even turn fatal. So it's very dangerous. Similarly, I'm very sure if you have ever been to the railway platforms, you would have seen birds sitting on wires, the telephone wires, and the bird sitting over it. And a lot of times, a very common scene from the railway platforms is that sometimes the birds are found dead. Let's say there are telephone wires, or there are some wires which are carrying current. Now, the moment when it is carrying current, at that point in time, so a very common scene which is seen from the railway stations and platforms is that sometimes these birds, they are seen dead on the lines. Now, do you know why? Because of the electric shock that they experience. Now, whether you talk about touching the naked wire, or you talk about these birds sitting on the wires carrying current, so they are dangerous because they can give electric shock, and this electric shock is due to the electric current which is flowing through the wire. Now, the electric shock can become very dangerous, and it can even kill an organism. So here also you see that electric current is a very important thing. So now we are all set to know what is electric current, because that's what we have been talking about since long. I have been giving you examples showing where do we see electric current flow. So let's understand what is electric current. It is the same electric current which makes the tube light on, which makes the fan start when you switch it on. So electric current is nothing but flow of electric charge. Now, the question is, what do we mean by electric charge? What are electric charges? So these electric charges are nothing but they are particles, and the particles are negatively charged, and these negatively charged particles are termed as electrons. So basically the movement of these electrons result in electric current. So how better can we understand this? So in order to understand this concept, let us assume that electrons are nothing but they are like balls, they are like particles. So we can see that electric current is measured as the rate of flow of charge. So as I said, charge are nothing but electrons, and these electrons can be assumed as particles. So how fast these particles are moving would determine how much is the electric current. So if they are moving very fast, electric current would be more. If they are moving very slow, the electric current would be less. So basically how fast or how slow the charges are flowing, that would determine how much is the electric current. So the unit to measure electric current is ampere, which is normally denoted by capital A, and that's how, so we define the amount of current as 5 amperes, 10 amperes, 20 amperes, and so on. So now when you look at this circuit, where we see that there is a bulb which is tied to a battery, this is a battery or a cell, and there is a switch. So let us say this is the switch. So this is how, now you might be amazed to look at this kind of a diagram. You might be thinking this doesn't look like a switch, but basically these are the ways to represent a switch or a battery or a cell. So this is how we represent them in an electric circuit. So we will learn about electric circuit a little later. Now as we switch it on, what happens? The entire circuit is complete, and as a result electric current flows through the circuit. And when electric current flows through the circuit, that this makes the bulb glow, and that is why the bulb glows. Now let us try to understand this concept of charges flowing from one place to another by considering it as a very simple scenario. Now let us say these charges, which are actually electrons, let us assume them as balls, because electrons are anyways particles which are extremely tiny, so they cannot be seen. Forget about naked eye, they can only be seen with powerful electron microscopes. So let's say these are the balls, and these balls are nothing but the electrons. Now these balls, as they move, so you see, as the first ball moves, the second one also moves, third one moves, fourth one moves, and so on. So this process of movement continues. So as the balls move, the rate of their movement, how fast they are moving, that determines the current. So the electrons are also like these balls. Now whenever these balls stop moving, the current in the circuit is zero, because the current is not determined by the presence of these balls. The current is determined by the movement of these balls. So as long as they are moving, there is a current flowing through the circuit. The moment they stop moving, there is no current flowing through the circuit. So that is the concept. So whenever we switch on, so what happens, all the balls in this circuit, they tend to move. But when the switch is open, in that case, the balls do not move. They become static, and as a result, there is no current flowing through the circuit, and therefore the bulb doesn't glow. So that is, in very simple terms, that is how the concept of electric current works.